Oh, here we go, live coding again. Pardon the noise from the next room. The topic for today is this studio development tooling that I'm working on, and what we want to do is get that we want to get that into shape a little bit. It's very new tooling. There's only a couple of kind of guinea pigs using it apart from me, and what I want to do now is kind of put that house in order a little bit so that it's usable for snab hackers to switch from LuaJIT to RaptorJIT, which is a huge thing. So yesterday I got a friendly poke from some other snap hackers, said, hey, what are we waiting for? Isn't it time that we made the big switch from LuaJIT to RaptorJIT? And I thought it through, and I thought, yeah, actually, it's in pretty good shape. So yesterday I submitted the RaptorJIT switch to snab upstream. We'll try to get that merged this month if we're lucky. Then everybody can ask questions about it at Folstom, and we all kind of meet up there in a couple of weeks. And the big difference between LuaJIT and RaptorJIT, or one very big difference, is that the analysis tools for understanding what the JIT does are completely different. LuaJIT has a bunch of tools, jit.dump, jit.v, jit.p, that run inside the process. So while the application is running, it kind of inspects itself and generates ASCII dumps to say what's going on. And I've had some problems with that in RaptorJIT. It's quite expensive, so you can't really use it in production. It's a little bit invasive, so actually running the tracing also, I mean, the tracing code also has to JIT. So the JIT is running and it calls out the tracing code, which then also has to JIT, and it needs to make a call out on every single bytecode that gets recorded. So it's kind of heavyweight for me, and it involves a bit of complexity with this so-called VM event mechanism for going out of the JIT back up into Lua code and looping back and everything. So I just took all of that out because I didn't like it, and I replaced it with something that I think is much more suitable for our needs, which is to just dump raw debug information as C structs really efficiently into files, and then to decode them separately. So that requires a decoder along the lines of GDB, and I built something very graphical called Studio to do that job. And now what I just want to do is get that ready for consumption by snap hackers, so that when they pull the next release, they have this new kind of high-level GUI tooling replacing the old ASCII tooling, and that it will kind of work out of the box for them. We'll minimize the kind of teething problems, and you know, get people pulling that update as quickly as possible. So this is a housekeeping mission, and we can take a look here. Well, rather here at the little agenda for now. So first of all, the studio tools. I had a different idea for how to do the installation. I think I'm going to just change the installation procedure. It's already simple, and it's still going to be simple, but I'm going to switch it from being like install a binary to make it just run out of the source checkout, to encourage people to have a read write checkout all the time, and to kind of operate out of that, to make it easier to engage with extending and that kind of thing. That's my thought. I want to update the manual for Studio, and this is actually kind of the manual also kind of doubles as a test suite, which we will see, because the manual has a kind of a complicated build process that actually involves running the software and generating screenshots by actually importing real data and actually running the application. So I haven't been very focused on continuous integration for Studio. I do have CI jobs set up to build the manual. I just haven't looked at the status of them in a little while. It's been mostly me just pushing code that I'm using myself. So I'm going to try and fix that, get things in a good state, and keep them in a good state. And then another thing, the Pharo GUI is written in Pharo Smalltalk. And Pharo Smalltalk has a lot of different ways that you can do, like revision control, basically, the way that you can track changes. And I haven't really come to a definite perfect solution for that yet that works for Studio. And one consequence of that is I think I've got some necessary code lying around somewhere on my hard disk that I need to pull in and push and make sure that I've got all the code that I want, to make sure that all my features I've been hacking on are kind of landed. So I'm gonna have a little bit of a look at that, which might involve a little, kind of searching a little bit. So let's start with looking at the Studio installer. So the way the Studio is installed with Nix. If you're going to install Studio, the very first step is always to get Nix. So what happens if you say get Nix? Getting Nix. So you would go here and you would run this as the first step if you didn't have Nix already installed. And Nix is a Nix is a package manager, basically, that does a similar job to like apt-get, kind of similar job to Docker and these kind of things, in the sense that it's gonna, let's think of it a little bit like Docker. It's going to go off and get software and install it somewhere that's out of the way, that doesn't interfere with your main software. You know, you could be running any distribution or whatever. It's just going to install software more or less as an image that's fairly complete, that's a little bit out of the way, and you'll only use it when you want to. So when we install Studio with Nix, it kind of goes, all the software goes in this folder called /nix/store, and it doesn't, doesn't go in user bin. It doesn't link with any of your libraries you already have. It just goes off to the side somewhere, and then we have a special way to run it. And the way that I'm doing it now is actually to install it. So the way that you would install Studio now, after you've installed Nix, is you would say nix-env install an attribute called Studio from. And then you would say where you want to get the Studio code from. Like I could just say this to install from my checked out copy. I could also say I could also refer to the master branch directly off GitHub like that. I could also take the next branch. I could also put a commit ID in there. So it's kind of, I quite like this about the current installation setup, that you can just give it a URL that refers to any version of Studio that's ever existed on any repository anywhere, and you can also use a local checkout, and it will just install everything. I mean, so if we do this with let's say the master branch, it goes off, it grabs that tarball, and it installs the software. So once we do that, we actually get a couple of commands in our path. Studio X11 that would run, if I have an X server up and running, it would run this graphically. And if I don't have an X server up and running, I could run Studio VNC. So if I just run that, then it gives me this VNC endpoint, and then I can connect to that. I actually already have one up and running, which looks like this. So now what we're seeing here is a VNC client, Tiger VNC, on my Mac connected to a Linux machine where Studio is running. So this is a VNC client running on my Mac that is actually running the code on Linux. So Studio always gets installed on Linux, and you can do it on a server, you can do it on an EC2 server, you can do it on a box in the basement, you can do it in Docker. So if you want to actually run it on your Mac, you need to have a Linux, but you can just use Docker to install any kind of Linux in Ubuntu or Fedora or whatever, and just run this, and then you do the VNC access, and VNC works very, very well. So for me, it just feels native. I don't notice that it's running remotely. That's a little bit the model with Studio. It also means you have a wimpy little laptop and run it on a beefier kind of a server, a Hetzner or whatever, and have some grunt behind it. So I want to change this though. So that was pretty easy, right? It wasn't very complicated to install, but I mean, it feels, I like to have it a bit of a more read-write kind of a feeling, right? So if we've installed this and now we have it in our path, but what if we want to make some tweaks? What if we want to do a little bit of fiddling and that kind of stuff? I don't really want to have to reinstall it every time. I'd like to be able to just tweak it and have it update live while it runs. And actually, I have already made it support that, so you can actually write something like, do something like this to make that work, so that it will always grab code off the disk. But anyway, what I thought might be a little bit simpler is to skip this whole installing things in the path business, and we just write, we say it's like this. When you want to get Studio, you do a checkout of the repository, which we have here. Let's hop on the master branch. You do a checkout of the repository, and let's just say you would just run bin/studio, and that's how it runs. And it would run it would always run out of the current directory. So if you want to have a specific, if you want to run the next, then you say git checkout next, and now you're on the development version. If you want to run the main line, you go like that, and then you just write bin studio, and that's what runs. And this is only a superficial change we're making. This is only really what the recommended, the default suggested way to run it is going to be. But anyway, I think for me, it feels significant, because I would like everyone who has Studio to be able to just quickly hack the code and have it immediately visible. I don't want to have any barriers to getting started. Like with Emacs, you're going to customize Emacs. You always have the extension, the scripting environment right there in the editor. You don't have to go anywhere separate. You don't have to say, now I want to go into another mode where I'm going to update the code. It's just always so. So let's try and capture the same feeling with Studio. So what we want to do now is just write a little script called bin studio, or bin studio VNC, I guess, that just does that. That runs it out of the current directory. So let's do that. Do we have bin directory? Yeah, there's already bin studio script, but I'm sure that's something old. And you know, I'm going to do this on a clean checkout. Which I don't normally do, but since I have company, I'll skip the risk that I have some funny things in my working directory that we're going to skip over. We do have bin directory with a bin studio. What is that? Ah, okay. Interesting. So there is a script called bin studio which predates the GUI. So I mean, these days Studio has this this graphical interface, but behind that there's also a lot of code written in Nix that does a lot of kind of data processing and this kind of thing. And that the back end came first and the front end came later. So in order to actually use the tools before I had a GUI, I wrote this shell script command line interface. And maybe we want to revive that one day, but the focus is actually on the GUI. So we're going to ignore this for just right now, and we're going to say bin Studio VNC. We're going to create a script called Studio VNC that runs Studio with a VNC endpoint. And once we have this working, we'll do the X11 version 2. So we're assuming, well, we've got to check that Nix is already installed, shall we say. So we will say if, how do you normally check if a command is installed? I think I maybe had that in the other script. I remember Googling that. That is how you check Nix is already installed, so we'll just do that. So we need to know that Nix is available, because that's the package manager that we're going to use for installing all of our other dependencies. And then, I mean, then we're going to use Nix to get Pharo, Smalltalk, and R, and you know, a lot of things that we use for our various tooling, and that's all taken care of by Nix. So all we need to have is Nix. If we have that, then everything else is going to get fetched automatically. So that's the only thing that we really need. Okay, and I guess that these checks are maybe worth having. You need to be on. Yeah. Let's check that we're on Linux. Why not? That's a bit nice. Fine. I have a visitor. Hey, buddy. What do you need? Just a second. Needed to provide a red airplane. Anyway, okay. So when the script runs, well, let's make this executable. Let's give it a first run now. Okay, fine. It passed the sanity check. It makes sure we're running Linux because that's what Studio expects, and it makes sure that we have Nix build available to make sure we have a Nix installation. So that's fine. After that, when we want to actually run, so let's look at the way our script works now. So we already have a script called called Studio VNC that does all the VNC server stuff. I'll pull that up just very briefly. And so all we really need to do is a wrapper to that. We don't need to do something totally new. We need a wrapper that just gets the software kind of installed and available and then runs it. So let's see where we have that other one. So when we install Studio, it generates this script for the VNC that runs a Tiger VNC server. It runs a rat poison window manager within that, and then it runs the Pharo Smalltalk in that. So the Tiger VNC provides a desktop. Rat poison provides a really basic window management, like basically just to resize the GUI's window if the desktop size changes, and then we have the actual GUI that runs in Pharo Smalltalk. So all we really need to do is run that script. So this should be really easy in principle. So we're just gonna. The thing is that to install Studio, you write Nix and -I. That's the basic incantation to install a package, and running Nix and -I will have the side effect of putting something in your path. So it installs software in the sense that it downloads it all, puts it all in the Nix store, and then it symlinks that from your path so that then you can use it. But what we want to do is not install something for later. We just want to run something. So we want to run something without installing it, or without installing it in the path. We just want to run it. And the way that you do that is like this. What you write is Nix shell, which basically just runs a shell command in an environment with certain software available. So we just want to run the shell command Studio VNC in an environment where all of our stuff is there, all of the rat poison configuration is generated, and the Tiger VNC is available, and the Pharo Smalltalk image is built, and all of that kind of thing. So this should actually be kind of easy. So let's check the man page for Nix shell. Nix shell. I believe we're going to tell it what packages we want. We're going to say that we want to have the package Studio available, which is our way of saying please install Studio. We also want to, this is going to get long, so let's do this. We want to run, what's the difference between -run and -command? Okay, -run for something that's not interactive. We want to run Studio VNC with Studio available. That almost might do it. Let's see what happens there. I think there's actually a couple of extra arguments we could add here that might be kind of handy. But for now, let's just see if that works. No shell here. Yes, we did. Undefined variable Studio. Okay. Okay. So for one thing, we're going to need to tell it what packages collection we want to get Studio from, and that's actually going to be a directory relative to this script. So how do we tell it? How do we tell it what path we want it to use? Just paging down to see how we. If any Nix gurus tuned in, please feel free to poke me in the comments. Tell me what I'm overlooking. What we want to do here. Okay, we've got some examples. What we want to do is okay. So we need to say. Do we need to say what kind of package collection we want to build, and then what we want to install from that? And what is this argument here? Is that a Nix expression, or what is that? Oh. This has the look of something we might want to do. Nix shell. We want to give it an expression. If we can provide a Nix expression to say what packages we want to run, then that's going to suit us just fine, actually. So let's try using this syntax here. Nix shell -e. The expression is in the parent directory we have we have our kind of code. So we want to just say import dot dot. That's the expression that should give us. That's the expression that should give us our package studio Nix packages. And then if we say we want studio there, we just say that's minus packages. What about if we do it even differently? We say that give an include path. Let's try this interactively. Hang on. So, okay, hold on. If we say Nix shell, what we want to run is the thing defined in the directory of find myself in knots here. There are a lot of different ways you can drive Nix, and some of them are a little bit fresher in my mind than others. Let's take a step back. We want to run Studio VNC. We want to do it with the Studio package installed, and we want to have that installed from the software collection defined in our own repository here in the parent directory. So I'm going to try, let's look at the example again. Where's on with the -e? So if we would say, let's try to use that one as a template now. With import what happens if we say that? What is the nearest example that they have to what we want? Here is an example that installs the standard default package uses the standard default package set to set up the environment for building the package pan. That's not what we want. We're not setting up a build environment. We're setting up a runtime environment. Also not what we want. This looks a little bit closer. Nix shell, give us the package pan installed from this. That looks much closer to what we want. So we want, if we do the Nix shell, give us the package studio from the package collection in here, then what happens? I want to call something that's not a function but a set. Possible that this is just a kind of interfacing problem. The way that we define our package set with Studio is that we import a baseline, we import a specific version of the Nix package collection that we've pinned. We import that doesn't have any of our code because we haven't upstreamed any of the Studio code, and then we put overlays on it here. And the overlays are where we add our own packages. The overlays, it just lets us add after the fact some additional packages to the standard collection. And that's where we put our stuff in. And this is the file that's being loaded by Nix shell here. And we go see. Why is it not happy? Attempt to call something which is not a function but a set. So it wanted a function. We gave it a set. So what was it calling? We just gave it. Do we see that? Do we see the entirety of that example down here? And we did the same thing. We said we want to install the package Studio and we want to use the package collection, which is defined there. So it kind of seems like. Oh, wait, hang on. There's more examples down here as well. Which might be worth looking at. It's possible that our package collection here is not in quite the same format, but this perhaps returns a set. There's something else. Can we get more debug information? Nope. So if we would compare with the standard Nix packages package collection, what do they return here? And so we are essentially taking what the standard package collection gives, which is going to be an attribute set, key value packages. Or rather, no, we're feeding this in, so this has to be a function. We import the base Nix packages there, and then we call that with a set argument, attribute set, which is a dictionary, overlays. And here it says we're attempting to call something which is not a function but a set. Backtrace is not from this file, it's from here. So I'm a little bit confused. I think I'm gonna just struggle my way forwards, trying different approaches. So what I'm going to try now is use a Nix expression instead of this -p -i. So if we would just say Nix shell, give it an expression which is import our package collection and grab the Studio attribute. It didn't like having a dot. Which dot was it bothered by? Is it that one? How about we would do that? Okay, now we got the same error. In a different way. So what about if we did that? Okay. So I think the thing here is that our package collection just has a slightly different interface than the standard one. So to make Nix shell happy, we should not be doing this extra call here. So I wonder if we can just change our interface here a little bit. I think it might be the easiest thing if we take this first question actually really is, we just change our interface here. This is working when we run it with Nix build. We're only getting a problem with Nix shell now. So we're going to make another file in our Nix directory. We're going to call this Nix shell packages, and I'm going to, when we're done here, I'm going to make an issue on Nix. I'm going to ask what is the correct way to do this. But for now, we're just going to do this, and it's going to say, yeah. Maybe that's overkill. Can we just get this doing what we want? We just say that we want to get a shell, which is going to be bash by default in an environment in which Studio VNC is available. Let's just see where we find that. Studio GUI VNC. So that's actually a step closer. Finally, what we have here is it started a subshell running bash, and it has made sure that in the path locally for this bash that Studio VNC is available. So to demonstrate that, or to check that, now we already had Studio VNC available, so we'll uninstall that. Okay, so now when we say which Studio VNC, we still have it. Okay, I don't know what's going on there. Why do we still have package after we've just removed it? I'm not going to worry about that right now. I'm going to keep going forward in the same direction, which is, but we need to think about how we're going to test this. So we need to come back to this very soon and make sure that we don't have any of the Studio software available in any kind of installed way, that we're only running stuff that we have out of the directory here. So I'm going to have to come back soon and see where is that installation coming from and how do I get rid of it. But first, go back to our command line that we had there. Wait a minute, we have so we had this as a starting point. Let's rewrite that ever so slightly. Nix shell -e import. That should have the same effect, I think. No? There's an ever so slightly funny syntax required in Nix when you refer to the current directory and the parent directory. Like you can't say dot, you say /dot. I had thought you could get away with that, but actually you need to say that to refer to the parent directory. I'm not sure why. That's somehow lexically required to differentiate paths from other things like URLs. So there we are. We've started a bash shell that now has the Studio GUI available, and it's this one particular version, and it's got the rat poison and all of that kind of stuff. So if we would just change that command to say, and we want to run Studio VNC, this is supposed to then start a subshell, make sure that that subshell has Studio VNC in the path, whether or not it's actually installed on the machine. And then within that shell, instead of giving us an interactive bash prompt like we got here, within that shell, just run Studio VNC. Okay, so that appears to have worked. And let's see if we can actually connect to that, because it runs Studio VNC, which starts the whole thing running in the background on a VNC server. So so the Nix shell has already finished. That's all finished, but it did start a process running, and we got to check if that process is Still running. On a VNC viewer. Source display number 9. Yeah, okay, there it is. So we did get Studio up and running, and it did the right thing. So this is promising. And now if we want to get rid of that, we need to do that at the VNC level. We need to say VNC server minus kill 29. Now it's gone. I guess you didn't see that on the screen region there, but now it's gone. Okay, so let's put that into our shell script then. Which was here, back where we started. So now we want to take what we did and put it in here. Nix shell and we're gonna, that tells it to import the Nix packages collection from our working directory here. So all of the software that gets, all of the software dependencies, you know, Pharo, Smalltalk and everything, that's all gonna get pinned versions that are defined in the same repository. So if we update this repository, then that's going to affect which software versions get used. And it's not going to depend on anything you happen to have had installed before. This will be a self-contained, out-of-the-way installation you won't see except when you run it through here. And we want to run Studio VNC. Okay, so is that it? In principle, we're done. Let's see if that works. Okay, that seems to work. Which is promising. So the idea here is if we check the script in, and you know what? Let's just call this Studio, and let's make this do both the X11 and the VNC versions. And you'll say we'll make it run like this. Make it say Studio VNC, something like that. Don't you think? Yeah. We'll probably over time evolve the command line interface here and make it a bit fancier, but this will be just fine for now. So we'll overwrite the old Studio script we had, like this. And when we get down here, we'll do this. We will say we'll give it a command line syntax. Right. Well, let's rather do this. Sorry, let me remind myself how to bash. I need to look this up every time. I would also need to look up when we go as far as to do get op stuff. I will also have to look up that. I need to look it up every time. Case statements in bash. Case 1, command list, double semicolon. Okay, fine. If we ask for VNC, then we'll do this. Ask for X11. And we'll do something very similar. It's short enough that we're not going to worry about that little copy paste for now. But if it grows in complexity, we'll take care of that. Otherwise, we want to do the error how about that? Let's just write wild massive amounts of shell code, hey? So if we say studio VNC, get this, and it runs. So is that finished? Are we all done there? Yeah, actually, I think so. So we're going to check that in. I'm going to create a topic branch. I'll do this with Magit. I sometimes use Magit is an amazing, fantastic, wonderful piece of software, and I sometimes use it, and I sometimes use the Git command line, and not especially systematic about that. For now, we'll use Magit, and we will say now we're on the master branch, and what we want to do is create a new branch, which will be called install load. And we need to do, which is the key of branch create. I got new branch. I want to the starting point. Excuse me. Starting at master called install. Here we rewrote that script. Okay, let's just see if there's any small thing we want to do there before we check it in. We define an error subroutine. We check that we're running on Linux to give a helpful message rather than something obscure if you would run this on Luminos or something. We make sure that Nix is installed, and if not, we give instructions to go and get Nix. Then we come down here, and if you say VNC, check that the X11 version works as well. I don't have an X server. Okay, no. Maybe it was just called GUI. Okay, that's basically as expected. It got all the software available and tried to run the Smalltalk environment on an X server. I'm not running an X server, so it's not a big surprise that didn't come through. That's fine. Okay, let me check this in on our topic branch. New way to install and run Studio. Studio is now installed. It is now run directly from the source tree without any separate installation step. Can now be. We haven't actually broken anything. We haven't done anything incompatible. But I'm going to change the suggested method of running Studio to be running this script. We'll give an example. bin/studio VNC run VNC endpoint. Required software dependencies are automatically downloaded or built without ever installing them in the system path. Fine, that's good enough. And you know, we might actually just briefly take this one step further. I'm not sure the best way to test this is, but when you ask Nix to install something, like when you ask it to install Studio, we've got some non-trivial dependencies, right? We need the Pharo Smalltalk VM, we need the Rat Poison window manager, we need Tiger VNC for the VNC server. So we're casually using a lot of software, and we're also pinning the versions of these things. And when you install something with Nix, it can either actually build the software from source, or it can go to what's called a binary cache and say, hey, I got this thing I want to build. This is the SHA-256 of all of the dependencies and build options and everything. Before I build this, do you have this already? And can I have that, for my platform? So it's very convenient if that happens, right? It can save a lot of installation time if you just grab binaries instead of having to build things. So as a user, when I run the installation here, Nix has already done a lot of caching, so maybe it only takes 10 seconds for me, but maybe it takes 10 hours for you if it needs to go off and it needs to get some R packages, and for those it needs to build a Fortran compiler and it needs to build a lot of Fortran libraries. Like I've seen this kind of thing happen, especially when we pin on a software version that maybe isn't in the standard Nix cache. So anyway, I would just like to declare two caches that it can use. One is the standard Nix one, and the other one is going to be the CI server where we're doing the Studio CI. So generally, any package you need has probably already been built and cached either on the standard Nix repository, which is building all the basic packages, but not necessarily. There's a risk that the specific versions we're using might have fallen out of cache, and also to check the CI server where Studio is being tested, because that's probably built exactly these versions. So we'll just check the Nix. It's a binary cache. Binary caches. Let us just see if we can pop into our script before we push it and say I think we say it like this. Minus option binary caches, I think it was. A list of URLs of binary caches separated by white space. Default being cache.nixos.org, and we'll also take hydra.snab.co, where our CI runs, and for the shell we might need to add a little bit more quotation there. And let's just briefly look if there are any other options that it seems worthwhile for us to look at. And this, I think when we run with Nix shell, is not going to be kind of sandboxed, so you should have all your files available once you're in and running, which is nice. Use binary caches, that already defaults to true. Might actually be a slightly nicer way to say X. And we don't depend on what the default value is. That way. Okay, I didn't see anything else that we obviously need to do, so let's see if that potentially. I don't know a really good way to test it now. I guess we could do a garbage collect of our local repository and see if everything gets downloaded from where. Maybe we'll do that. Let's just see if it works first. Okay, it did get the extra arguments. and it runs. Okay, so let's try. Nix select. That might take a moment to run, I don't know. So the thing is that every time you build anything with Nix, it gets cached in this Nix store directory, and it's marked with the SHA-256 of all of its build dependencies. So that's the compiler that was used, the libc version that was used, the GCC options, everything goes into that hash. So then when you come and want to build something again, and then the complete source code and everything. So when you come on, you build something again, it can check that SHA-256 and see if it already has it. And if it doesn't have it, then it can go out to these binary cache servers and see if they have it. So it's kind of a very kind of very disciplined way of doing caching, where you're very particular about exactly what it is you're trying to get. So now we're deleting lots and lots and lots of stuff out of our local cache. So in principle, then when we need to build something, it might actually need to compile things. We might say if we want the Pharo Smalltalk VM, it might have to build that. And actually the one that we have for Pharo Smalltalk is a custom packaging here in Studio. So it would not be on the standard Nix packages server because it's not upstream. There's a different version upstream. So then in principle we would have to build it locally, although now that we added this option to check a second binary cache, which is the CI for Studio builds, it might actually be able to download that from there. So actually it might save a bit of build time in the install. Yeah, but that's presumably going to take a moment to run. So let's commit the change while that happens, because it seems to work. So we come back here, and what did we do? We always back this commit out if we're not happy with it later. Okay, that's checked in. So let's make a pull request out of this. Let's push this and make a pull request out of this, just for the moment, just so that it is somewhere. One of the things on the list today is actually fishing around on my hard disk to find a little bit of code that maybe I either didn't push or didn't push correctly. And so I'm just going to, for the sake of good hygiene, I'm just going to take this thing. We're still going to do a little more testing on before we want to merge, but we want to make it visible and easy to find already now. So let's do that. We will. We already have a nicely named branch. We don't have my repository as a remote, because we just did this clone today. So we'll declare that remote. Oh. Installed update. And actually, we're going to need to update the README as well, aren't we? That's the kind of, or is that in the manual? The next thing we're going to do after this is to look in the manual. Let me just check if the README. Manual is the next thing, but do we have already the kind of running step in the README? No, it just links to the manual. Okay, so maybe we should actually here have a little quick start, but we don't have it now, so we don't have to update it. So that's a separate thing. Fine. Push this. And we'll make a pull request out of that. So add, create a new interface for running Studio. So this runs Studio from the current directory without requiring any installation. This is proposed as the default way to run Studio. Fine. So the point here is that if you want to get a particular version of Studio, you want the master version, the next version, some specific commit, you have your own custom version, you're merging things, whatever. You just do that with Git, and then you run it out of your local directory. I'm gonna create that now. Have a pull request there. We'll come back to. And actually, one more thing I want to do already now. It just passed my mind. I've already forgotten it. Hold on. I'll open the script. I'm sure I will remember. One more thought had just crossed my mind. There's something that was worth adding here before we push that. I'm trying to remember what it was. I was multitasking a little bit too much. Run it in VNC mode. Run it in GUI mode. Always have this. No, it'll come back to me. We might do another push here if that fleeting thought comes back before we merge that. So that's looking all right. We're still doing our Nix garbage collection, and maybe we'll even just interrupt that. It's probably got rid of something significant. We'll just kill that, and we'll just once more test running our DNC. So in principle, this could take hours now actually to run, because I mean I'm hoping this binary cache makes sure that it doesn't, but it's a while since I updated these pin packages, so it might be overdue. So it might be that those I probably picked a conservative version to begin with. It's possible that they fell out. It's already finished. I mean, anyway, when we do this installation, in principle, it can build a lot of things. I have seen it the case that it needs to build like a Fortran compiler and a bunch of Fortran libraries, because I was referencing an R package, and that whole tool chain was the version that I was referencing was not in a binary cache anywhere. So I think that we're pretty safe from that actually now. We're going out both to the standard Nix packages repository that has all kind of semi-recent versions of everything already cached, and we also go out to this CI server that builds Studio specifically. So it should actually have exactly the versions that we need built recently, at least for recent versions of Studio. I suppose that if you go into a very old version of Studio, in 5 years' time, if you would come back and try to run the version that we're looking at today, you would probably have to stuff would probably have to be built, because it wouldn't be in any of the caches. But enough about Nix binary caches. Fine, that's under control. What was our next thing we were going to do? We were going to look at the manual. So I'm going to take a 5-minute break before we look at the manual. And the manual is more interesting than it sounds, because the manual is the build process for the manual actually runs the whole GUI and automatically takes screenshots. So it's like half manual, half test suite, you might say. And this is actually built on CI. And the thing is, I'm just not sure what state it's in right now. I know that I've added a bunch of features that I haven't updated the manual, so I might need to add some more screenshots to demonstrate those. And I also wouldn't be surprised if I broke something, because as I say, Studio I've been using mostly myself with a little bit of guinea pig help from people like on the Snab Slack channel. But now I'm trying to get it into a state that it's kind of always in good shape, and anybody can download it and run it, and following the steps just works. So now I kind of want to nail down a little bit better get the CI tests running well, including building the manual, and make sure it's up to date, and make sure that it's building successfully. So, short break. We'll run our short break script. So here we are again. Let's pull up our to-do list and see where we were. We had just updated the installation process for Studio and made it a little bit more streamlined, or a little bit more to my current taste. We'll see. There's a lot of different ways you can do that, but we have one that looks promising for now. Okay, and the next step is to refresh the manual. So the manual, as I was just saying, the manual is built actually by a continuous integration server. The manual, it's built, on the one hand, it's a markdown file that gets run through Pandoc, which is pretty simple. On the more exotic side, it includes a lot of screenshots, and those screenshots are automated by the build process for the manual. And it's like when it's doing I'll show you. Well, we'll pull up the manual so we can see this. If we pull up the Studio repository, then we get a link to the manual, and that's actually linked to the continuous integration server and the latest build for the master branch. So what we see here is something that has built automatically on CI, and that's a canned screenshot. But if we go down a bit, this for example, all of these things, here we have a profiler report based on some standard benchmarks for RaptorJIT virtual machine. And the way that this screenshot was generated is that the build job for the manual actually downloaded the JIT compiler and built that and ran all the benchmarks and got all of the profiler data out of them, and then started the Pharo Smalltalk GUI and imported all the benchmark results and pulled up this specific tab and then took a screenshot of that. So it's really, the manual build process is a kind of an end-to-end thing, which I think is kind of nice in the sense that you know that it's up to date, right? Whatever you see in the manual was actually generated by actually running the actual software. So if we break something in the software, we're going to break the manual as well. And I don't have any sophisticated ways for checking for that. I know that there are actually some pretty cool tools around for doing things like doing diffs between images, so that we would quickly be able to see which screenshots actually had a visible difference from one build to another. It would be really interesting. I don't think we need that yet because we don't have enough of them. But anyway, so we have all of these screenshots here that are all getting generated, and this is fine and nice and everything. And you can see here, you can get a feel for what happens. Like this shows you the Studio under the hood on the RaptorJIT side is a little bit like GDB. Then we take raw C data structures, we get the dwarf debug information, and then we kind of browse around on a very low level. This is the fields in a C struct. You can expand these to chase pointers. You get all of the types with all the type defs and everything. This is all very fine and nice, but what we're looking at now is the manual for the master branch. So the question is if we would be very, very brave and open the manual for the next branch, the development branch, would anything actually be working? And I'm not sure, because I haven't been very disciplined about following the CI for Studio, because I have been treating it kind of as my own hobby project to a certain extent, just sharing it with some guinea pigs. And I'm transitioning out of that mode now. So now I want to get a bit more serious. So I've been resisting. I've been resisting a little bit, looking at the manual for the development branch, because maybe it's all totally screwed up, maybe it doesn't build, all that kind of stuff. Let's have a look now and let's sort it out. So we pull up the CI, we go to the Studio jobs. Perhaps the manual is being built just in my little place here. Okay, so the Studio manual for the master branch is building okay. The Studio manual for the next development branch is not currently building okay. We can see the log of all the builds that have happened. So the last build that actually worked was based on this git commit. So apparently I broke something when I pushed this version here, and it has stayed broken. Yeah, so that happened in December. So it's been broken. The development branch screenshot is well, the tests are failing, you could say, on the development branch for the last month or a little bit more, which is not that cool, right? But again, a new project, whatever. I'm not going to beat myself up about it. Let's see what the problem is. This failed. Why did it fail? Got a segmentation fault, apparently. That's interesting. Kind of looks like I pushed to the Raptorjet support in Studio. It has support for actually running Raptorjet programs. So in the GUI, you can actually say raptorjet.run and give it some source code for it to run. And that means it needs to actually download and build and install Raptorjet. And I haven't specified any version here. So there is a kind of a version that is the default for Studio. And it would be possible to override this because this is a Nix expression and you can do anything in a Nix expression. You would just need a few examples to look at. So in principle here, you could tell it you want to build a specific Raptorjet, go off to GitHub and get this commit or something like that. But it's just building the default one. And it seems like one of the test programs got a seg fault with the specific Raptorjet version that is the default for Studio. And I think because I've been doing this this GUI support based on some kind of work in progress features of the Raptorjet VM. So the version that I'm using as the default in Studio is not actually from the main line of Raptorjet. It's from one of my own private development branches. So that's not getting subjected to CI. So it's been working very well in my interactive happy testing. But it might actually be that it's broken, that particular branch. So why don't we see? Let's see which version we're running. When we run, so just to summarize, in case that wasn't clear, it seems like the problem is when it tries to build the manual on the next branch, it gets a seg fault running the JIT compiler to generate the data that it's going to use for making screenshots. And I think that what I did, we can check actually. So this is the change. Update Raptorjet support. I would like to get a diff on that. I think we'll find that I changed which version of Raptorjet should be used, and I probably switched it from a good working version to a broken version from one of my development branches. Can I get that as a diff from Hydra? Yes. Okay. Yes, I do have it as a diff. Raptorjet. I updated quite a bit of stuff. I also updated the base Smalltalk image and everything. But here we see the default version of Raptorjet. I say get it from GitHub, from my user account, repository Raptorjet, and previously it was this revision, and now it's this revision. So this revision seems to be broken. So let's hop over, have a quick look at that. What was that? Okay, so audit log is a development branch. If I pull that up, this is a really long-running branch that I've been doing, which makes the VM generate copious trace debug information in an efficient way. And I've been developing that code specifically for supporting the Studio GUI. So so what I've been doing is I've been referencing my development branch from Studio. So Studio needs this bleeding edge feature for development purposes, but it doesn't really seem worth landing that feature on Raptorjet mainline until the Studio tooling is ready. So it's been this kind of a codependency thing where I just do everything on development branches. But we're beyond that point now. Now things are actually in quite good shape. So now it's probably a good idea to just try and get everything merged together. I think it's the right time to do that. So let's make an integration branch that merges this audit log an integration branch for RaptorJIT takes this experimental audit log feature and merges that with the current master, and then we'll see how that works, see if we have a problem with that. But first, let's see if we can reproduce the error here. If we do git checkout there, so now we have a RaptorJIT checkout. We switch to the same commit that seems to be causing problems when we run the test suite to get data for the manual. So what about if we just run the test suite now? If I just say Nix build, then it automatically runs the test suite at every different optimization level, just as a basic sanity check. So it would be very convenient if this fails now, because then we've reproduced the problem that we saw on CI locally. And here we see, because I had done that garbage collection, I'm missing a lot of stuff from my Nix store, so it's getting a whole bunch of packages, and at this stage at least it's not having to build things, it's managing to find them on it's getting from cache.nixos.org. So there's a bunch of dependencies that are being referenced by RaptorJIT now that I've garbage collected out of my local cache, and so Nix is downloading them. Ordinarily that just happens very quickly because you have it cached after the first time. Like now I have everything cached again. Anyway, it's built, it's running the test suite. The test suite passed, and that's a little bit of a pain because it seems like there is a problem, but maybe it's actually the benchmarks that expose the problem rather than the test suite. But because I've had two parallel paths of development, I've had the main RaptorJIT where I've been kind of doing more stable things, and I've had this audit log branch where I've been mostly just focusing on one feature. Maybe I've got a fix on the master branch that is missing from this branch. So actually, let's just do it in the easiest way. Let's just take the audit log branch. New plan. We're going to take this audit log feature branch, which may actually already be more up to date compared with the one that is being referenced by Studio that we're having a problem with on the manual. We're going to take this and we're going to merge in the master branch to make sure that we're not missing any fixes. And then we're going to test with that, and we're going to try not to do all of our testing on the CI server because that's just a bit lame. We're going to get it running locally. So because we have Nix, we can also run the this manual build just as easily on our local machine, and we'll get all the pandoc and all that kind of stuff. Nix will worry about getting all of those dependencies. So step one is get an up-to-date version of the audit log branch. So let's say, I think we're on our audit log branch already. Yes. Let's fetch the latest upstream. Okay, so it didn't pull in anything much new, so it's kind of interesting. So, well, hang on. So now we've pulled the latest changes into my audit log branch. The question then is, was the CI using the latest version of the audit log branch already or something older? So that's the commit that it was testing on. So actually, what is the new commits that we have here? From the version that the CI was testing to head. Okay, it's a lot of stuff. Actually, a lot of stuff has happened on this branch after. That surprises me a little bit, but that's the case. So a lot has happened on the branch since that. So excuse me here for a second. We hop back to CI for a moment. So we saw the first time a build failed, it was when we switched to this particular RaptorJIT version, but we've had quite a few failures of the manual. So that was one failure, and another, and another, and another, and another. So actually the latest, now we're interested in kind of the latest code that's failed, which is that one. So it's not to say, so it might be that a problem started here and has been carried forth on that audit log development branch. Anyway, what we're going to do now is locally, away from the CI, we're going to try to build the manual first to just reproduce this error that the CI has here. Let's make sure that the latest error is the same as the previous one, which it may or may not be. It's not. Okay, so wow, live coding, huh? So just backtracking a bit, we had the manual building fine in September. We pushed something in December that made it break. We've done a bunch more pushes since then. They're also broken, but it seems like it's broken for different reasons. So this first breakage was because we pushed a bad version of Raptorjet that crashed. This latest one, that seems to be failing for different reasons. See, it's all of the PNG files, it's the screenshot generation that's failing. So that's kind of interesting. So probably we don't need to dig into that first error that we saw because it's already been fixed. Probably there was a bad version of Raptorjet that I pushed, and then I since fixed that error and pushed a better one. But then there's a different problem, which is that the Smalltalk code for generating screenshots is failing. So this is kind of more like the kind of error I was expecting, actually. So I know that I've been a naughty boy and I haven't been making sure that I'm keeping the manual building cleanly as I hack the Smalltalk code. And I also know that my workflow for pushing Smalltalk code into Git is not that ideal. It's a little bit error prone the way that I do it. It's very easy to accidentally forget a method or a class somewhere when I'm exporting code out of the Smalltalk image and then checking it into Git via Emacs. So I know that there are better ways to do it, but I just haven't had the whatever the word is. I haven't been bothered to kind of fully internalize all the different ways that you do Smalltalk code. These days, there's this new iceberg tool that is the latest and greatest thing. You have this, you can do things with chain sets. I'm using this Monticello, Metacello that I kind of hate at the moment. But anyway, I digress. Let's just fix this, hey? Let's reproduce this off the CI on our local server first. Then let's fix it. So step one, reproduce. So we hop back where we had Studio already, which is actually here. We can use this repository that we're in. We'll just check out the next branch, which is the one that should be broken. And then in the doc directory, we have a default.nix, which should build the manual. So we might be able to just run that. Let's see. Nix build doc. What happens? Aha, that's interesting. It was rejecting some cached files. Okay, so when it tries to pull things from our binary cache, which is our CI server, it says it's lacking a signature, and so it's ignoring it. That's kind of interesting. So this, you remember when we updated our script? Where do we have that? We had. Okay, sorry. We're not on that branch anymore. Anyway, we should go back to our script and either make sure that the signature is available, or just tell it not to use the signature for that particular server, which is probably also fine. We need to come back to that. But that's on our topic branch. We've already hopped over to the development branch, so let's not try to do too many things at the same time, unless it becomes an actual barrier. So now, now we're paying the price for my garbage collecting, but it's nice, I guess, to keep this in mind. So the very first time, look, it's downloading LLVM version 4, it's downloading GCC 5.4, it's downloading LuaJIT 2.1, it's downloading Clang. So with Studio, my basic idea is that you'll probably run it on a server. I'm actually running it in a server on my basement, so it doesn't have the world's fastest internet connection, but it's decent. But my notion is you'll run it on a server. You may very well have several people running Studio on the same server, sharing the same cache, and the notion is that a little bit like with Docker and these kind of things, that Studio has a big image that includes all of the software that it is in any way interested in. But hold on, I might be able to parallelize that. Sorry, let me just say this to get a bit more parallelism there. So while that runs, yeah. So the first time you run it, it's going to have to download a fair bit of stuff and potentially build some things as well. And that's all going to disappear later. So it's a bit of a bummer, of course. The very first time you run it, it'll seem like it's really slow to install. Then later, it will be much quicker. But my notion is you would put it on a server. So Alan Kay has this idea of an alto. as a machine of the future. It's a machine that you can get your hands on that is the way all machines will be, in 10 or 20 years. And I kind of feel like if you go to Hetzner for, I don't know, like $100 a month or something, you can get a server with, like an AMD server with 24 cores or something, and a gigabit internet connection and all kinds of things. Anyway, my thought is just that Studio is something where it's a development tool. It's supposed to be very powerful. We're supposed to be able to be very ambitious, do big things with Studio. So the thought is that we'll run it, generally speaking, on beefy servers and access it from wimpy little laptops. So this is an apology of sorts for having for allowing quite a few dependencies, for allowing, depending on R, depending on Fortran compilers, depending on specific versions of GCC and Clang and everything. Anyway, let's fix this problem now. So it is specifically the screenshots that fail. So it manages to build the Pharo VM, presumably, and it manages to build the image and load all of our software. But then when it tries to build a screenshot, it looks pretty straightforward. We pull up the code. It looks like I just removed one of the things that was getting screenshotted, and that caused an error. Maybe we should handle those errors more elegantly. Anyway, let's pull up the code for doing a screenshot. This is the Nix code that generates the screenshots. So it actually does this raptorjit.run on a little program. So it actually, when it's building the screenshots, it actually runs the raptorjit VM with an example program in order to get data that it can then import into the GUI. So it runs two example programs. One is this tiny little example here, and the other is it actually runs the full benchmark suite for raptorjit. So this is just kind of an easy thing to do. I wanted to get some representative looking profiler data, so I just run the standard benchmark suite with profiling on, and that gives us what we need, some interesting data to include in screenshots. And then it goes through here. We have this function Studio Inspector Screenshot. Gives a name to the screenshot. It says which object in the GUI we're referring to, so which Smalltalk object we want to access, and what is the name of the view, which is the tab. So traces overview. So if we just pull up the manual again, the one where we had it, when we had a working build. Where do we have traces overview here? Okay, so it didn't find this, so it's entirely possible that I just deleted this because I've been churning a little bit on the GUI. So I don't think we have a traces overview thing anymore. Just give me 1 second. Okay. So let's start by removing the screenshots that don't exist anymore. See if that gets us a step further. So if we pull up, and what do we actually have? We have totally rejigged the GUI since this was done. So if we're looking at a trace, we have an IR tree, an IR listing, and we have bytecodes. Those are the three things that we have. So let's do those instead. Bytecodes, IR listing, IR tree. Here, this is on a process. There's all these different objects in the GUI, and these are screenshots not on an individual trace, but on a whole process. So we need to look at that again. This is a process. So what do we have? We have events and we have VM profile. Those are our two things that we have in processes now. I took away the other ones because I at some point decided they were confusing. Events. And we had profile. VM profile. And why don't we try to get the manual built with just those? Let's cut down screenshots. We'll gradually introduce them again, because I think there's a reasonable chance that those will be generated okay, but let's just introduce these one at a time, kind of. So if we pull up the build the manual again, which screenshots? Oh, we're currently, okay, we're already building all of the screenshots, but then let's just comment some of these out, shall we? We're gonna get, oh, that was wrong. That digit, no, process VM profile, that was right. What about if we just remove these for the moment? I'm not sure. Can you do a multi-line comment in Nix? I'll just check that quickly. It would be convenient. Yes, you can do multi-line C style. So we will comment out the ones that we haven't got sanity checked yet, and then we'll try to build the manual again and see what happens. Okay, so at least one screenshot, it says taking screenshot, took screenshot. Some things are building, some things are working. We got an error at the end. What is the error for now? Did audit log not found? Hang on, I'm going to rebuild that without parallelism, just to be a little bit more clear, just to get one error that we can start with. There was a Smalltalk error. So that's actually kind of interesting, that message. That might be the root cause of it. Git audit log not found. And that was while building, which screenshot? While building the VM profile screenshot. Couldn't find the Git audit log. So, what about if we would debug the build of this screenshot specifically? This is more kind of Nix food that I'm not so, I kind of need to look up every time. Anyway, what we want to do is take a closer look specifically at the build of this thing here. So, where does that build? It's in the screenshots. And it was rapid process VM profile. So I want to try and build that expression all by itself now. Nix build. Is that the same failure? Yes, it seems to be. I'm assuming that this is the root cause there. Okay, good. So when we have that failing, we can then say Nix shell and say we want to get in the build environment. I think that this is something that you do. I think this is what you do when you have a build failure. You say drop me into a bash shell that has the build environment for this screenshot that I'm trying to build. And then we look at our environment here, and we'll see. Let's see the definition again first. Need to find where we got that function from. This is the code that generates a screenshot. What does it do? It takes a whole bunch of arguments, the name of the file, the code for getting a Smalltalk object we want to inspect, the view, the name of the tab that we want to see, and then the width and height of the screenshot. It declares that it needs to have Pharo Smalltalk available to run this. It generates a script, a Smalltalk script that's going to do what we need. So this splices in that code to get our object, and then it loads this Glamorous Toolkit inspector, gets it in a presentation, and then it goes through and finds the tab with the right name, and then it uses the built-in support in Pharo for dumping the screenshot to disk, and it's out and it's done. That's the Smalltalk code. It generates this script as a part of its kind of build environment, so we should actually have this script in our shell. We should be able to see this generated code, which will be handy. And then to actually run the build, what does it do? It grabs the Studio Smalltalk image into the current directory, runs it, telling it to run the Smalltalk script and then quit, and then it copies out the screenshot. Okay. So I'm thinking we should have an environment variable called Smalltalk script, possibly, if I'm looking in the right place. Let's see what we've got anyway. We should be able to find some of these things, I think, via our shell. Yeah. So the generated Smalltalk script has that file name. So let's just open that up. I don't have a Smalltalk mode installed for Emacs. So in order to get an object to inspect, it says we want to instantiate a wrap-digit process from a path, and here is the path. So that is where Nix has built our input data by running wrap-digit. That's actually kind of interesting. Let's see what is there. So if our root problem is that it can't find an audit log, you call this search and failure and JIT audit log not found. If that's our problem, then it's entirely possible that this is the directory that is supposed to have an audit log, but doesn't. So let's see. I mean, yeah, that directory has it has a lot of the things that we expect to have, but it doesn't have the JIT audit log. It has profiler data, it has dwarf debug information. Well, it has the raw dwarf debug information in ELF format. It has this in JSON format, which was some pre-processing done by the Nix code. Behind the scenes, it has the output of running yes, that's the output from running a benchmark, but does not have an audit log. Okay, so that's interesting. So why not? Why is there not any audit log? And also, I guess it's in the no, the audit log just should be there. Let's have a look. Why didn't we get it? Let's look at how the screenshot again produces the data that it's going to use to inspect. It does wrapdigit.run and it does wrapdigit.run directory. Is it possible that one of those API functions is broken? Again, Studio doesn't really have a CI suite running at the moment. The nearest we have is this manual that is built by CI. So if I've broken something on the API, it's entirely possible that this is where we'll see it. So CI has to be improved for Studio, and I guess that's what we're doing now. But it's not all there yet. So let's have a look. I've been using this command interactively just all the time, but it's possible that this one that tells Raptorjet to run a directory full of Lua code that it downloads from somewhere, like in this case it downloads a benchmark suite from GitHub. It's possible that is somehow messed up so that it doesn't produce all the necessary data, like the audit log. So we're going to look into the Studio backend, where it deals with Raptorjet, and this is our little API for running Raptorjet code. And I notice actually at the top that the comments are out of date there, so we're going to need to fix that or migrate that into the manual. But anyway, one thing at a time. Run, I think, is working. Run tarball and run directory, I'm not so sure about. So how do these work? Let's look at the working one first. The run function takes an argument called Lua source, which is going to be a string, and it provides two outputs. One called raw, which is just what the Raptorjet process outputs when you run this, and one called product. Product is the name in Studio for something that has been prepared specifically for Studio to inspect. So I think in this case, we can see up above, but the raw version will give us the profiler data and a lot of stuff, and the product will then do a little bit of extra pre-processing. The key thing there will be the product will convert the dwarf data from ELF format to JSON format. So basically the product does any extra steps after running the program that make the software easier to inspect. In this case, it's a bit of pre-processing on the dwarf data. But anyway, eval string, eval tarball, eval directory. The question is there some significant difference between those where one of them produces an audit log and another doesn't? Eval string. Eval string calls eval file. It takes a string, writes it into a file, and then runs eval file. So eval directory. So there's a little bit of, okay, it probably is something, well, we see a bit of duplication here directly, right? Like eval directory is copying all the files from that directory and running Raptorjet probably with not quite the right arguments and everything. Whereas when you tell it to run a string, then it writes that string to a file and then runs the file differently. But anyway, why do we need a function to run a file when we already have a function to run a directory? Can't we just prepare a directory with one file in it? Probably. So I think we're just going to merge these eval file and eval directory together, and we're going to have to make sure that we pick up probably this argument here to produce the audit log and make sure that we have that down here as well. So let us just compare them to start with. Set minus x we don't need. So we're going to fix it eval directory, which is probably pretty straightforward, right? The way we run Raptorjet there, we tell it we want to start an initial profile to initial.vm profile. This is so that if you don't set up any profiling in your program, that you already have something up and running. So by default, it creates a profiler dataset called initial.profile. Raptorjet actually has an API where you can define multiple profiles and switch between them to kind of compartmentalize the performance of your program into different components. But you're not always using that, so we have a default startup there. So that is something we want, and that is something we already have down there. But what we don't have is this writing the audit log. It seems to be the only thing that we're missing. That's looking already better. And then this thing, if we actually get an audit log, like if the program didn't terminate without doing anything that would cause it to be created, possible the program wouldn't produce an audit log, for example, because it doesn't do anything, never invokes the JIT. So we want to have that. If we got an audit log, we want to copy that into the output directory, so that we don't just discard it as part of the run. We want to keep that. And we want to pick up all the .vm profile, all the files named something .vm profile, and we want to put them in a folder called VM profile. And it looks like we had a nice folder. Okay, we already had that there. And we already had the audit log thing there, actually. Okay, so we already had the test to see if we have an audit log, and if so, pick it up. Well, then maybe it makes more sense up here. So from the top, this is probably okay now. Have them both on screen for comparison. When we want to evaluate a directory full of Lua source files using Raptorjit, we create our output directory. That is debug printout. We copy all of the inputs, all of these Lua files into the current directory, which is a temporary build directory that Nix has created. We then run Raptorjit with an initial profiler dataset with an audit log enabled. We run that on all of the Lua code in the current directory. We save any output, including standard error, to output.txt. Then, if we did get an audit log, we migrate that into the build output directory so that that will be available. We then do the same. We make a VM profile directory in the output, and we copy any profiler datasets that were created anywhere, so when you run Raptorjit and you access the profiler API, you could put the profiler datasets anywhere in subdirectories, whatever. So we pick those up and we put them in a well-known place where the GUI is going to be able to find them, the VM profile folder. And we copy also the dwarf debug information from the version of Raptorjit we actually ran with. We copy that into the output directory as well, so that the GUI is going to be able to use that for decoding the data in the audit log, which is raw C structs. So it gets decoded in the same style as GDB. So that looks fine, but now we want to get rid of, we have too much redundancy here, right? We don't want to have eval file anymore, because we already have eval directory, and when we run eval file, then we just kind of want to run what's the easiest way in Nix to just say this file we have, just put it in a directory, convert this file into a singleton directory. First, let's see if we even need to do that. That is already going to be in a directory, so it would be very nice to be here to say eval directory, and if we get write scripts to give us not the file name but the directory name. No, hang on, let's do this in a way. Let's do this eval code, and we're going to make it take a file or a directory. Fix it at the bash level. So when we eval a table, it will be eval code, and don't need this eval file anymore because everything is just eval code. That's where we're going to say if the source is a directory, then copy the directory contents in. Eval could that possibly work? We just, when Nix gets us to build, it already creates us a fresh build directory. So we create the output directory. We're going to copy the stuff we want to keep after the build, and then we check is our input a directory. If it is, then copy all of its contents into the build directory. Otherwise, we assume it's a file, and we copy just that file into the current directory. In either case, when we come down and run with star.lua, we're going to run everything. Let's try that. Might work. So we wanted the Nix build, probably that. Looks good. I'm going to find a directory. Our code. I'm able to open VM profile just as well. Profile wrong somehow. Not create regular file. Back to that. What did we get now? We've got an error. Trying to get this process VM profile screenshot. So just refreshing our context a little bit. Trying to screenshot this specific view here. It's got a Raptorjet process, and it's trying to get the view called VM profile. So it wants to see something like this, but not based on the same data that we see there. Got an error at the Smalltalk level. It's kind of hilarious in some sense to be debugging Pharo Smalltalk errors via the command line in the Nix build environment, because this is totally foreign to Smalltalk. But I mean, if it's not a huge time sink, I'm just going to continue doing it here, because this is our build environment. But if it's complicated in any way, then we'll do it interactively in Smalltalk image, of course. So what was the error? Where here is the actual error? There was an assertion failed. Load file name. It looks like a very similar situation. It's not specifically saying they couldn't find the audit log, but it certainly looks like we're getting an error on trying to load file. So why don't we look at it in the same way that we did before? Let's see what we're actually getting. Let's see what we're getting out now. See if the change we made actually had any effect. Do we have an audit log file? So last time we looked in the Smalltalk script that's going to take the screenshot, and we looked for where that is looking to get its data. There is an audit log there. So yes, basically the problem we were trying to solve before was that file was missing. We fixed that, and that fix worked. It still isn't working, so maybe something else is missing. Let's have a look. Well, you know, actually this kind of interesting. What if we would just run this code here in our graphical Smalltalk we already have up and running? We take that, hop over to our Smalltalk environment, we open an ordinary workspace, and we paste that in. And what could possibly happen when we run that Smalltalk code in the Smalltalk environment? Hopefully we get the same error, but with the debugger, and we can click around and get a better idea for what's going on. But let's see. Yes, that's the error. And now, because we're not on the command line, we're in the real environment, we can say debug that. Let's expand this a bit, and let's go walking down the stack a bit. So it was trying to open. Okay, it's trying to open vmprofile/raptorjet.vm profile. We saw a permission error about that earlier, so I'm not sure if this file is supposed to exist. I wonder where this is coming from and why it has a permission error. So this, But this is also interesting. The assertion that failed, and naughty me for not giving the assertion a meaningful message, but it's asserting on the version number of the profiler data. So somehow, I think this is a stray file that's gotten into our build somehow. Somehow, we're getting a file called raptorjit.vmprofile, which I'm not at all convinced was supposed to be built in our setup. And this seems to be an older file, an older version that's not compatible with the GUI. So I've made a few versions of the VM profile file format, and I haven't done a lot of backwards compatibility because it's mostly been me using it up until now. So anyway, where is this raptorjit.vm profile coming from? Is it something in my build directory, for example? First, let's see if we have a file of that name. Here. No. It's coming from somewhere. Somewhere we're getting that file, and we don't want it. Could it be... I think that once upon a time I accidentally checked in a profiler dataset in the little throwaway Git repository that contains a benchmark collection. Let's check. And I remember fixing that, but so it might be. Let's see if it's fixed in the current version, and if so, is that the one that we're actually testing? This was in the RJ vmprof bench repository. So we saw earlier that the manual build process is going to download a benchmark suite for raptorjit and run it in order to produce data that's going to feed into the GUI. So is there a stray file in here called raptorjit? Wow, so that's not really meant to be there. This, I think, is the JSON version of the dwarf debug info, so that should probably not be there, although I don't think it would cause that problem. But if we look at the history here, I want to see commit. Yeah, so at some point I removed this raptorjit.vm profile that was stale, and I removed some other stuff, and it looks like there's even some more stuff I should remove. So which version are we actually using when we build the manual? Are we using like this old version before we took out that file? I would not be surprised if the answer is yes. Just give me 1 second, please. Okay, yeah. So are we running an old version of that repository with some junk in it? And is that tripping things up? Let's see. Where are we going to look for that? That's going to be in. That's where we generate the screenshots. There, with Nix, when you reference something that you want to include in your build, you pretty much always have to provide the SHA-256 hash, because that's the thing that makes all of this caching work. That everything is built very precisely. So we've referred to this Git revision, A70C2. Is that a good one or a bad one? That's a bad one. Okay, so we're running this old version. So we would like to update that dependency. Use this one instead. And we're gonna poke that in here. And actually, we also need to update the SHA-256 match. But I'm just going to give it an invalid one and then get the error message saying that it's wrong, and use that to do the update. See what I mean? So I'm going to do the Nix build now. What I'm expecting is that when it goes off to get this dependency, it's going to say that the SHA-256 was wrong. Yes, it says this was expected. What I actually got was this. So let's take that one that I actually got. And let's put that in here so that everything will be better. Now when it tries to build the manual, it's going to get a newer version of the benchmark suite. And it's going to verify the SHA-256 of that to make sure nothing changed on GitHub. I mean, it would be pretty hard to change. Well, will be reasonably advanced to change the code on GitHub and keep the commit ID. But anyway, checking the SHA-256. That wasn't building the thing. That was just getting us into the build environment again. Where do we have a build? Nix build, taking screenshot. So it looks like we got the screenshot now. Right. We can copy that across to our Mac. Sanity check it graphically. Let's do it. Build result will go there. Browse it. Put into test screenshot. Yeah. Okay. So we got the screenshot now, which is nice, which is great. So this had been broken, and now that is working. We see though that I don't have that up here. And now I closed our window where we were inspecting things. But anyway, we can improve this as a next step after we get the basic manual working. We can improve this by writing some Smalltalk code to come in and to select one of these, and then there'll be another pop-up and select something there. So we would like to drive this GUI a little bit more to make the screenshot more interesting, but that's one step further than what we need to do right now, I would say. Now I think we'll be satisfied with just generating such screenshots as we have, removing the old dead screenshots, putting in the new ones, and getting that building, and then we can kind of tweak again. So let's just charge ahead a little bit with that. Instead of building just that, let's try building the whole manual again, see where we're at. Something failed to build. Yes, I think we broke the eval tarball function here. What does eval tarball do? It has a URL. It says evaluate code of the fetch tarball. Where are we there? Eval tarball script on line 2. So it kind of has the look that it's trying to run Lua code as shell, right? How would that happen? How would we end up? How would we end up? End up feeding Lua code to the shell. Sorry, but that might be the wrong name. It should be eval code. Might actually be in here. That's also a little suspicious. Unable to open the end profile. So it did actually run the Lua code. And after that, other Lua code was problematic. Go back to our screenshots. It's this, isn't it? So we're running raptor.run and we're passing in a string in Lua code. So I think we broke raptor.run. It takes Lua source, runs eval code on that Lua source. And that's the problem. Wasn't it previously doing a write script thing? To turn that string into a file, I believe it was. So just jumping around in a diff here. No. We want to do that. We might need to come in and take away some of those old methods. But anyway, what we want is this. I'm going to take that string and convert it into a file by writing it to a script called eval. Give a catchy name, shall we? Lua. Now let's see what happens. We were passing Lua code where a file name of a Lua script was expected. That's why Bash ended up running it. Now some stuff seems to be running. We could actually parallelize this build if we wanted to get things faster, but yeah, so some things worked, but we did get an error eventually. VM profiles. Let's hop back to so this. I don't think we want to build that screenshot right now. There might also be something that doesn't exist anymore. Let's just build 2 screenshots. A manual with 2 screenshots. See how we go. Trace overview. Where does that come from? This is okay. This is from Pandoc now. That's a bit better. So now the manual is complaining that we built 2 screenshots and they both succeeded, but then when we went to actually build the manual, we're referencing images that don't exist. So let's pare that back a little bit. Studio.md. Here is our manual. And what do we do? If we come down where we reference the screenshots, here in the manual we're accessing the screenshot that's automatically generated, and obviously we're referencing some that don't exist anymore. So for right now, and I'm thinking we might actually wrap this up a bit, because we've kind of done the I don't know how juicy these bits were. It's documentation maintenance, but we've done the juiciest bits, I think. If our sub goal now before we break for lunch is to just strip the manual down a little bit and successfully build it with just those 2 screenshots that are already working. And that's going to be removing some stuff that we might have to put back, moving some stuff that's broken and should be gone, and also perhaps removing some stuff that's broken and should be fixed. That'll be the next step. We'll break for lunch, and that's not necessarily that exciting. So which of the 2 screenshots that we have? It is events and VM profile. So we're just going to take away trace overview. Trace list we don't have. VM profiles we do. VM profiles with an S, we have VM profile. We will have to put back a bunch of stuff there. Okay. Process 2. That's all a bit broken down there. New events. Write a blurb for that, but first we'll just the screenshot in. And it's also on the same presentation for the process has one view called events that looks like this. It also has a view called PM profile that looks like this. That could possibly work. So there'll be 2 screenshots there and a bunch of text that's missing some screenshots. And if we get this building, we'll be happy. We'll celebrate with launch. And it actually seems to have worked. Let's copy that across and see. Video.html. So we got a manual from Pandoc. And this is a screenshot that's not generated. That's canned, so is that one. Then we come down somewhere in here. Yes, this is a screenshot that was actually generated by the current code. It shows us actually in a previous screencast we improved this listing a little bit, and I haven't committed that anywhere. So actually, one of the other to-do items for today was to go and find some of these enhancements that I haven't mainlined. It's very nice to have the manual then pop up to remind me that the code actually on the development branch looks like this, which is not necessarily the way I want it to look. And then we have the other screenshot there, and then we have missing screenshots down there. Okay, I think we're done for now. What we've done is revived the manual documentation build for the next development branch. We fixed a couple of screenshots and we removed all the others. And the next step after lunch will be to synchronize that to make sure for each piece of functionality that we have, we also have an appropriate screenshot. And then we're going to be golden, and we'll push that, and it'll get built by continuous integration all the time, and we'll always be able to look at the CI build of the manual to see exactly how the development version actually works, because the screenshots are generated by running the software and built by CI. Anyway, that was kind of a not very glamorous day of morning of live coding, but I guess you can't have rock and roll all the time, eh? Thank you very much for tuning in, and goodbye.